Thank you for joining me today. My name is David Dickman, and I work for Cloudera. I head our marketing group that handles advanced analytics and artificial intelligence. And with that, we've been working with a lot of organizations to help them modernize the way that they both manage and understand their data, and then turn that data into business value. So my talk today is on real-world success, unifying architecture for analytics with Iceberg. And before I begin, I just want to cover a little bit of what we're seeing in the marketplace today that's driving folks to look at their data management, look at their analytics, and prepare for artificial intelligence. One of the first things we see is that today there's a lot of investment in generative AI. How many people here have been to a session that mentioned generative AI? Right, everybody. I think every session mentions it. But when we look at what's happening in this space, we see a lot of folks today focusing on things like conversational interfaces, natural language processing, chatbots, easy answers to easy questions on safe data. These things aren't really where we differentiate business value, but they're a great start. These include things like marketing content, personalization. These include things like in healthcare with proactive care treatments and automated pre-authorizations and the sorts of things that help us kind of move the process along. But the next wave of AI, and where generative AI will really pay dividends and help us differentiate our organizations in the marketplaces we participate in, this is going to come from rich, trusted agents that are working on your most sensitive and secure data. Because that's the data that you have that's an asset to your organization. That's the data whose business value differentiates you from others in your space. And if you can harness and understand that data better than anyone else, you will leap ahead in being able to convert customers, retain customers. Things like having rich consultative agents that are working together to give you a deeply tailored experience. We call this sort of the concierge experience, where customers will engage with your corporation in that trusted exchange. Here is some of my personalized information in exchange for higher value goods and services from you. But it's also helpful in doing things like getting better health care. So one of our customers that we work with, they're actually using life sciences data and generative AI to mine thousands upon thousands of medical images to come up with novel treatment plans for rare forms of cancer, where actual research does not yet exist, and are getting much better results with what generative AI is projecting to use to treat these cancers than what they would come up with on their own. So these things can not only just improve our businesses, they can also help save lives. But to prepare for the next wave of generative AI, we need to make sure all of our data is ready for use in a trusted way. So how many people here trust all of their data to AI? I don't think I see any hands up. That's smart. We got a smart room here. And so the other question is, how many people know where all their data is? And so these are the problems that we're trying to help customers solve, because the more data we can make available to AI in a trusted way, the more value we can get from that. So 3 architectural patterns have emerged to help us do that: the data mesh, the data fabric, and the data lakehouse. And when we look at how these form themselves in the marketplace, we see data mesh is really looking at your data strategy and is far more focused on organizations than on technology. In fact, we argue you can't just go and buy a data mesh, install it, and have a data mesh running in your organization. You have to think about who the people are and rethink about organizing your data, not as data sharing at table level, but more as data as a product. So that's where the data fabric comes in. Data fabric is implementing that strategy using technologies. So the data mesh is the why, the data fabric is the how. And this is all about technical orchestration of data assets in a way that basically hides us from the complexity of how that data is managed in another domain. So if you have your finance domain, your sales domain, your service domain, your manufacturing domain, it doesn't matter if they're using completely different technologies, completely different ways of storing and managing data, if we're sharing it in a abstracted but completely useful way. So data fabrics are there to help us coordinate the sharing of data irrespective of the technologies behind. And the lakehouse, this is where the data management actually happens. This is where the rubber meets the road. This is where we see those domain practitioners and the day-to-day data practitioners interacting with the data within their given domain. This is a way for us to take all of our useful data, structured, semi-structured, unstructured, put it together, operate on that data, prepare it for use, secure it, govern it. And the lakehouse paradigm is growing heavily because it allows us to remove a lot of the silos. How many people here have data lakes? And then data warehouses? And have you started combining them into lakehouses? And here doing the lakehouse? Yeah, this is an emerging trend. We're seeing a lot of folks moving to that. The reason why we're seeing this happen is we see 7 barriers to the successful reuse of information cross-domain in a traditional data lake, data warehouse type situation. The first barrier is as we bring all the different data sets together. Structured data, unstructured data, real-time data. All of this data is going to end up being segmented into 2 different environments using completely different sets of tools. The second barrier that emerges is around that unstructured data not being able to take into account the structured data. And by that same token, the third barrier we see is around that structured data. We'll have a completely different workflow and a completely different data lifecycle around the structured data. Now that's great because we can then immediately go and start producing SQL reports from that. But that's only part of the picture we want to tell. Remember, this structured, well-curated data in a data warehouse, this is about being able to count everything once, only count it once, don't forget to count anything. This is the kind of information we use to rely upon paying taxes to governments, where you can't say things like, well, more or less with a margin of error, it's about this much I owe you. You have to be right about that. And you have to be right in a lot of different use cases on data warehouse type data. But the unstructured and semi-structured data can tell us a broader story. This is where we look for those patterns and correlations. This is where margin of error is acceptable. If we look at something, let's say, social media about brand sentiment. If I say that I am 85% brand positive response to your social media, plus or minus 5%, you're going to make the same business decision whether it was 80, 85, 90, but it's still meaningful business value that we got from this imprecise data. So having these in separate houses and working on them separately creates additional challenges when we go to get those augmented dashboards that include the statistical analysis together with that structured analysis. So here's where we bring in the data scientists and we start churning through this unstructured data, finding hidden patterns and correlations and meanings, and we can add that to our dashboard, and that's another whole step in the equation. But then the next barrier we encounter is how do we bring in some of the most modern technologies we have available, like AI, machine learning and AI. This tends to be yet another process we do in yet another corner, separate from all the other work that we're doing, to finally get to those predictive dashboards or other intelligence we can infuse with AI. And all the while that we're doing this, we're learning about our data. We're learning new things about the data, learning how it works for our business, what it's useful for. But if we don't have a closed feedback loop, which is our 7th barrier, bringing all of that new metadata together and storing it for the next iteration, we have to repeat this process over and over again. So let's enter the world of the open data lakehouse. The first thing we do is we can use the same tools now to land all of that data into the lake portion. Now, your traditional data warehouse uses extract, transform, load, or ETL, right? So this is, I take the data from the sources, I do some transformation, and I put it in the warehouse ready for use. What we're talking about here is moving to an extract, load, transform. Bring all the data in at scale. Put it in the data lakes. By the way, these data lakes, and I said plural on purpose, the data lakes are all these different storages you have. They could be S3 buckets, they could be in ADLS, they could be on-premises, and still treated as a single cohesive data lake. So we're not talking about physically co-locating all of your data in just one storage, but it's about logically looking at all of that data as one data estate. So we bring all of that in with the same tools, and then we do the transformation. So extract, load, then transform, so we can still get that precision we need for those data warehouse use cases, like paying tax to a government. All of this is still being done in the same technical environment. And because we have the semi-structured and unstructured data together with the structured data, and as we go through these transformations to get that well-curated data, we can also use those same transformations to prepare the unstructured and semi-structured data for use in augmenting those dashboards. And in this same environment, we can start training models and building AI into the entire equation. So the data scientist is now part of the whole team, not something that's happening off in the corner. Everybody is collaborating across the entire life cycle with the same storage paradigm, the same sets of tools to get you a single cohesive result. So at the end, you get straight out of the gate that augmented dashboard with predictive analytics, with AI infused in it. So this dramatically simplifies your architecture and streamlines your use of the entire data lifecycle. You can dramatically reduce the number of ETL engines you need to run. You can dramatically reduce the different types of storages and storage conversions you need to do. And you can reduce the amount of data hops or movements you need to make, and ultimately deduplicate a lot of the storage of the same information being transformed in slightly different ways to many different types of analytics. So the Open Data Lakehouse, powered by Iceberg, allows us to bring all the different tools necessary for all the different practitioners who are going to collaborate on the data and have them all work on the exact same type of data. All these engines, open source engines like Spark, open source engines like Trino, open source engines like Impala and Hive, they'll all operate. We're looking at Kafka, Flink, NiFi, all operate on Iceberg, all read and write Iceberg. Not just the same type of data, the exact same data files themselves can now be operated on by multiple engines at once. Now, of course, with this proliferation of this new table format out there in your enterprise and bringing in all other sorts of data together with it, one of the biggest challenges is, of course, how do you maintain security and governance? So for that, we see a single layer, a federated catalog and meta store, bringing all of the information about how the data is moved, how the data is stored, how the data is governed. But we also capture the business descriptions, like what does this data mean? What level of curation is it? How is it useful? Do other people like it? Is it a good data product? All can be brought together regardless of where the data is stored. So this is the Open Data Lakehouse architecture powered by Iceberg. And one of the things that Iceberg breaks is this monolithic architecture we've been seeing. Now, even with the movement to cloud, where we saw the separation of compute and storage, this was great because it allowed us to independently scale compute and storage, freeing us from some of the barriers that we had in our on-premises appliances and monolithic architectures. But we still had this notion that there was some kind of compute engine that had its own meta store over its own visibility to the storage. But Iceberg breaks that paradigm. The table format from Apache, called Iceberg, allows all of the different engines to work on the same tables at the same time, regardless of where they're stored. So we get a real many-to-many relationship between the things that we use to operate on our data and where that data lives and exists by speaking a common language over that data. And this really frees us up to use this data in more creative ways. So data lakes, data warehouses, very monolithic, but the Open Data Lakehouse is meant to be free of those barriers and restrictions. So I've said Iceberg a lot. How many people here have heard of Apache Iceberg? These lights are bright, so I can't see all the hands, but I see a few hands up, good. So Apache Iceberg is an open source table format project started by Netflix, contributed to by many other vendors. We have Apple, we have LinkedIn, we have Adobe, we have Netflix still participating. We're a participant, AWS participant. The reason why we're seeing Iceberg as a phenomenon in the marketplace today, when organizations like Snowflake list the word iceberg, referring to this table format, over 20 times in their latest financial statements, this tells us that the market is demanding a way to free ourselves from having to always work with a specific vendor to share our data more freely and be bound to that vendor's engines and infrastructure and other choices that may limit your ability to use that data for the best purposes and best value for your business. And so Iceberg has emerged as the standard. We've seen organizations like Databricks purchasing Tabular to get access to Iceberg. And we've partnered recently with Snowflake directly so that as we make Iceberg a standard with Cloudera, and they make Iceberg a table format that they will look at outside of their own, that it works correctly together. And we're doing similar operations with AWS, because ultimately this is going to be the de facto standard for large data sets in cloud moving forward. The reason why it's doing that is because it has a lot of great capabilities that take your data lakes and give them all those data warehouse-like capabilities that are necessary to have that new open lakehouse architecture not be a compromise of both worlds, but really be the best of both worlds. So it's compliance to SQL behavior and correctness with full ACID compliance, which means that you have transactional guarantees so your data doesn't become corrupt while more than one engine is working on it. But we also have the ability to do things like schema evolution. For anyone who's ever worked in a relational database, it's not hard to add a column or change a data type in a database. You don't typically have a big expense, but in a file-based system, like we see in cloud storages and like we see in data lakes, having to recreate all the files behind because you've added a column and retrain the metastore with this new information and share that among all the other engines that are going to be looking at that data can be quite expensive. But with Iceberg, it's dramatically simplified. You can change schema on the fly, and all new data sets created will use the new schema, and it remembers what the old data looks like, so you don't have to take the hit of maintaining tables while structures change. So how many people ingest data from third-party sources and those structures change willy-nilly? This is one of the reasons why this is important, because that helps keep up with that. Hidden partition and partition evolution. This is a great advantage to Iceberg as well, because with this, when we need to change the way we're partitioning the storage, and partitioning the storage is basically a funky way of making the right files have the right subsets of data in them for fast retrieval. But as data sets grow and your business needs change, you may discover, I didn't really partition well for tomorrow's use case. Well, we can just simply change the partitioning mechanism. All new data will use the new one. Old data stays in the old one. Again, you don't have to take a big expensive maintenance hit to change the partition of your tables. Multifunctional analytics, this is the real magic trick here. So for those who want to get a little bit technical, what Iceberg does is instead of storing all the information about what all those files mean and how they relate to each other to give you the sense of a table that spans hundreds, thousands, millions of files, it puts that information next to the file itself. So all the metastore, which is the bottleneck of accessing this kind of data, all the metadata that needs to be stored in the metastore is, this is where the table begins. And then the file system knows what the files are all throughout this table architecture. The cool thing about that is that other engines can be interacting with those files without going through the metastore as a bottleneck, which means they don't have to wait their turn quite as often as they used to with older paradigms, or we don't have to worry about the impact of those changes like we used to because we have the ACID guarantees, so we don't have to block whole users out while we take whole big long operations on the data, which means we really can share the same data as it lies in our storage versus having to make copies of it and replicas of it and other tricks to ensure this works, creating duplicates of data that can lead to errors and additional cost. But one of the other nice tricks is this time travel. Because the metadata is stored with all the files, every time we make a change, we can snapshot it. It's a metadata snapshot. It doesn't burden the metastore, so we can do this all day. Doesn't explode our storage, which means every interaction with the Iceberg table is remembered, and you can run a query as of a given timestamp. It will find which snapshots belong to that and recreate faithfully what the data looked like at that point in time. How many people here deal in regulatory compliance and regulatory industries, regulated industries? Yeah. This is a great tool because the way we do this before is we'd create copies of those tables and say, okay, that's the November tables, that's what the data looked like, because you can't just rely on the date ranges of the data records themselves because they may get modified later and no longer represent what the data looked like at that point in time. With Iceberg, this is automated. And because it's a file system, we still suffer. How many people have heard of the small files problem? Yeah. So Iceberg's still going to have that. But because of the way that the metadata is handled, the impact of it is significantly less than what we've seen before in the past. But also, we still have the ability to do compaction and vacuum and all these other things that clean up the snapshots we're not using, clean up the small files. And this can be automated with intelligence to improve the overall efficiency of these tables. So when you are paying for those compute cycles in the cloud to get the business value out of your data, you're using less and less of those compute cycles when these tables are optimized. So Iceberg comes with all of these great capabilities. And lately, innovation continues in Iceberg. So we now offer branching and tagging in the Iceberg table format, which allows us to create different sets of data. And based on the tags that you use, you can access different sets. Very useful for doing things like remembering data sets for model training and other experiences that you may be looking at that need different versions of the data at different times. Most commonly, we see this being used in dev test scenarios. It's not recommended for production. Materialized views. So anyone who's doing traditional analytics, how many people enjoy all those 5-way and 8-way joins and things like that you get to do in traditional structured SQL programming? Materialized views allow us to pre-build a lot of those joins, which can dramatically reduce the time it takes to retrieve information from the Iceberg data sets without having to change the structures as we define them. That's what makes the data easy to understand and share, is that it's well organized. We don't have to change the organization just to improve performance. We can use materialized views as a tool to help us get there. Change data capture allows us to not just be able to keep these tables up to the latest real-time data coming in, because a lot of what we're dealing with our customers are real-time problems. Change data capture can also be used in replication, where we need to have the data co-located with different compute engines in different environments, where the absolute lowest latency is essential. So what we're looking at next with Iceberg is focused around performance, interoperability, and collaboration. Remember, the nirvana we're trying to get to is shareable data products that are safe and secure and trusted, so we can make that data available to modern architectures around AI. So the first thing we're looking at is the Cloudera Lakehouse Optimizer, which is an intelligent tool that runs over your Iceberg data estate and runs at the appropriate times the compactions and vacuum functions on the right data sets, so you're not wasting time optimizing tables that have low utility or running this during peak time and choking your system's performance, yet still making sure that we get you the best performance out of the Iceberg tables so you don't pay too much for your cloud compute. Interoperability, there's a new innovation that's emerged in the Iceberg world. This is coming from the Apache Iceberg project itself, and it's called the REST catalog. The REST catalog allows a vendor to provide an interface to Iceberg tables that it manages that another engine can access without having to have another engine in the way broker that communication, or having you have to recreate that metadata to identify and understand the Iceberg tables and its security outside of a single managed environment. So this is what allows us to use something like Cloudera's data platform to give you a single security across your entire Iceberg data estate and share that data freely with engines that come from AWS or Databricks or others in the future, Snowflake and others in the future. Because ultimately what we want to get to is the ability to use information everywhere. And this is where the Trino engine and Trino's integration and full integration to Iceberg is also a project that we're sponsoring to allow us to be able to use the federation capability to operate on the data where it lies with the lowest amount of latency possible. So we don't have to copy and move all of our data to get good performance, and we can use data wherever it's born without having to move it and copy it and keep it secure. And finally, around collaboration, this is where we really get to that human interface so that we can go to a dashboard of some sort, go to a data catalog, find the data we like, and just go and use it. So data catalogs, data clean rooms, all these things we need to be able to share data in a technology-independent way from how that data was originally born and used, so that we can get that ability to truly use information for all of its secondary purposes further down the line. So the Lakehouse Optimizer, one of the cool things that we've noticed is in our testing, we're getting up to, I can't read that number because my glasses aren't strong enough, 69% cost savings. So we are finding that you spend 69% less compute cost on optimized Iceberg tables versus Iceberg tables that are left unmanaged. Having this automate that versus having you to have trained people watching the tables and making human decisions as to when to optimize will get you that return on investment very quickly. And the REST catalog is what we're talking about as a way to be able to share in both directions Iceberg data without having to go through things like JDBC, ODBC interfaces and run different engines. Because remember what we were talking about before, the whole idea is you don't get to the data by asking my engine to go through my metastore and get it. You go directly to the data by asking my metastore, can I compute on it directly? And this really lets us plug in at a different level in that separation of compute and storage. We also talked a little bit about how the lakehouse participates in a bigger world of architectures that allow us to get to the ability to make data products. And this is about going from where we started. We solved this problem by having the monolithic legacy-type environments that were very rigid, very limited, very expensive, but gave you that single version of truth. But then the cloud came along and allowed us to do things like just grab some cloud resources and get things done, gave us tremendous flexibility. And we enjoyed this flexibility for some time, but we noticed that there's some challenges with that. By being disaggregated and all over the place, we have a security issue. We have risk that comes from that. And we have additional costs. We can easily find ourselves in an organization doing the same things on the same data the same way in multiple places where it's fairly wasteful. So the idea of fabrics and meshes is to rein in that chaos without stifling the freedom and flexibility that comes from the cloud. And this is what a typical data estate looks like. When we're dealing with organizations, and I know we're here at AWS, very close partners with AWS, the majority of our customers for the cloud are choosing AWS. Can I just get a show of hands? How many people here have more than one cloud to work with? Also have Azure, also have Google. It's very common, and it's actually a common practice that we see in the industry, have more than one vendor provide the same service. So we often see organizations that look like this, that perhaps we're running manufacturing or marketing is in AWS, and sales is in Azure, the research and development department's working on Google Cloud, and we still have on-premises data. How many people here still have data centers on-premises and likely will for some time? There's nothing wrong with that. So on-premises data centers or private clouds are also things that we're seeing in a data estate. So what ties it all together is if we think of each one of those environments as open data lakehouse nodes on a fabric, what ties the fabric together is a single view of the data management itself. Single view of your security. One security profile for all the environments shared together. One metadata catalog. Federating all the metastores from all the technical engines that operate, bring all that information together so you have automated lineage, automated heritage, automated traceability, which helps you with your governance and regulatory compliance needs. We also can provide data observability over all of this information, because even if we're not managing that information, if we understand how it participates in the ecosystem, we can tell you what the quality of that data is, what the consistency of that data is, if errors are introduced in that data, which helps you in improving the quality of your products. And also, by having this entire estate being viewed as one, we can easily do things like set up federation and replication so we can connect disparate data sources together and reduce latency. So this global enterprise data mesh implemented by the techniques of a fabric, which is centered around that data catalog and centered around metadata, is what's going to give us that visibility and control over our estate without reducing the need for the freedom of the cloud. By the way, we just published a blog, one of my favorite blogs we published recently. Our chief of product, he published a blog called The Data Turf War is Over and the Metadata Turf War has Begun. Because what we see here is by freeing the data, especially with something like Iceberg, freeing the data from a vendor's engine as the mode of control and access. The metadata now becomes the mode of control and access. And organizations that have good metadata strategies will be able to use more of their data in a safe and secure way than organizations who do not. So the data mesh, we talked about this in the beginning. Data mesh is an idea. It's not a product you purchase. It's not a reference architecture. It's not a tech spec. It's not limited to IT departments. It's a business idea. It's a set of principles. It's putting people before technology and business understanding and value before implementation. And it's ultimately an organizational culture shift. So, one too many. So it's based on 4 core principles. First, decentralized ownership. So the owner of the data is the one closest to where that data is most used, the domain. These are the people who understand that data best. Finance people understand financial data. Manufacturing people understand the telemetry coming from the Internet of Things. These organizations know their data best. But then the second principle is, now that we've given each domain its responsibility for its data, we know that cross-domain data sharing is needed. So instead of just giving my tables up and say, have at it, you figure it out, we're going to treat these as a product. Now, if we think about a physical product, what do we care about with that product? We care about its quality. We care about its capabilities. We care about what versions they are. We care about how complete they are. We care about service guarantees. If I'm going to run my department on your data product, and you give me a guarantee that it's got 99.9 uptime, I'm going to be happy with that product. If you're going to give me a guarantee that that information is going to have a certain level of quality and completeness and accuracy, I'm going to rely on that. And now that we have data products we can share, the other tenet here is, well, I should be able to just go share them whenever I want. I shouldn't have to go somewhere else and find the data, figure out whether I can use it. I want self-service to this data infrastructure, which ultimately necessitates single source of control for security and governance, because I should be able to go to the marketplace and, if my role has authority, see the data sets that I'm allowed to use. It needs to be easy to find, easy to use. I should be able to go to a catalog and search for information that looks like what I'm trying to solve in my analytics. But to do that, we need to ensure that we have federated our governance so that we get that one single central view of all of this for that control and security that we need to be compliant, to be safe. And that data catalog, that federated governance, needs to have data observability with automation. So this is where we're able to put in things like rules over the data. Data that looks like this will be flagged as personally identifiable information and redacted from those who should not have access to it, without limiting access to the other data surrounding it that may be useful as your product. So automatic classification of data, automatic tagging, being able to do prohibition on data sets or masking of certain subsets of the data. Have these be time-based, have these be location-based. Whatever is necessary for us to be sure that we put the right guardrails in place. And what I like about this one is, when we really think about it, better quality security doesn't limit the flow of data. It actually increases your freedom, because if you've done your homework well here, you can trust more people to have more self-service access to more data without fear of giving the wrong data to the wrong person and violating regulations, or worse, leading to a data breach that can get you into trouble. So this becomes the backbone of an enterprise data fabric. Being able to have a single source of metadata to bring it all together, single security, encryption, quality encryption over all of that data as necessary, be able to have the control over the data and its movement throughout the enterprise, and be able to have all of your governance rules co-located into a single spot. And that's where data management really is playing a big role. And then the data catalog that manages your data products needs to be able to give you all of the nice visuals that go with that. Being able to discover and find data, to be able to like the data, to be able to comment and dialogue about the data between the data owners and creators and the data users, to be able to star rate the data. And all these social dynamics that go around the use of data in your enterprise should be part of this, not just the cold, hard math. Being able to see the data's heritage and lineage, be able to see the quality by each attribute will be an important part of using this data. And you need it with role-based access control. You need it with table, column, file, whatever layer of granularity. You need to have that flexibility to increase the amount of data you can share without having to give away the store. And the last big trend that we're seeing really pushing this dynamic is this notion that natural languages are going to become the new way to talk to our data. So if we look at the picture on my left, your left, yeah, on the left, the triangle. If we want to work with all of our data, we are constrained by the boundaries of technical interfaces. How many people here are an SQL expert? I shouldn't even have my hand up. So it's a limit to being able to have democratized access to data. But now with things like chatbots over our data, natural language to SQL generation, and what AI and natural language processing bring to us is an ability for anybody to use a human interface to explore data, to access data, and to get business value from the data without having to work through the technical interface. We're dealing with a large manufacturing company. They have a room full of very smart, PhD-level material scientists. They do not speak SQL. They have data engineers they collaborate with. And the way this normally goes is, hey, I want some data about some material research. Can you go help me curate that data? And they'll come back with a data set saying, is this it? And they're like, nope, that's not it. Try again, try again, try again. Ah, finally, that's the data I like. Build me a permanent pipeline of that data into this dashboard. But imagine we give them the tool to do the data exploration themselves. Well, they may still not be skilled with this to create that permanent pipeline. They'll know very quickly what data it is they want the data engineering team to invest their time in optimizing for them, versus all the wasted cycles back and forth, which can sometimes take months just to hone in on the right data for research. So now they're getting to data in minutes, what takes months, and are using that data for business value immediately. So what we talked about so far is that open data lakehouses are the fundamental component, node if you will, in a fabric and mesh where we're going to do all of our operations on our data. But we're going to combine these lakehouses in different clouds and on-premises across a single fabric that allows us freedom of understanding and free flow of information throughout our enterprise. And if we build this with the philosophies of data as a product, data decentralization, federated governance, we will apply the principles of the data mesh to our business and culture and truly gain the advantage of data democratization, which will increase the amount of data we can make available to new use cases and increase the trust we have on that data that we can use it for AI and get the benefit of AI to our enterprises. So here's a couple of practical examples we have in industry. One of the places where we're seeing Iceberg itself play big dividends is in consolidating the lakehouse, the lakes, and the houses into a single lakehouse architecture. So what we see, even in cloud, we see all these cloud data warehouses with their own engine and own storage, ETL going to each one, lots of third-party data warehouses, lots of third-party ETL, lots of third-party storages, and the BI engines operating on all of that, giving us business value. But when we move to an Iceberg centralized data estate, we put Iceberg over all those storages. So we're not moving the data out of where it's born, we're just looking at it as a single Iceberg data estate. We do extract, load, transform, and dramatically simplify all that ETL and ELT and data flow and streaming stuff that is coming in spontaneously through each of these warehouses into a single cohesive part of the process. So by using a single source of data flow and streaming and a single source of data engineering, we can dramatically simplify the architecture, dramatically reduce the number of data duplication, and take a lot of complexity out of managing our analytics estate, yet still be free to use any engine we want. So the users that are familiar with their favorite BI tool, their favorite SQL engine, they can still use those without change. No rewriting of business apps, dashboards, or reports. Now, we're also working with a company. This is the Halifax Airport Authority out of Canada. The interesting about this airport, and why I like this story in particular, is they are the 10th largest international airport in Canada. How many people here are from Canada? I can raise my hand for this one. So the big joke is there aren't that many airports in Canada, so they're not big. They're still an international airport. They still have to adhere to all of the rules and regulations and standardizations that come with being an international airport, but they have a very small IT team. And so while they're building an environment that looks at all of the different sources of data, By being able to use Cloudera and Iceberg together, they're able to use the data in AWS and in their on-premises data center where regulatory requirements still require them to maintain a certain amount of their data. And they're able to get all the data practitioners to use all their favorite tools to access that data. And they've been able to build use cases faster and more intelligently than some of the much larger airports who have not yet made this lakehouse conversion. And guess how many people they have in IT running this environment today? 1. So when we talk about the challenges that face large enterprises, we're really not talking about being a large enterprise. We just find that the complexity of data challenges get bigger as corporations get bigger. But we're really talking about a way to handle the challenges of a complex data environment and simplifying the complexity in the form of management in a single cohesive way. So this is an example of a marketing organization. They needed to bring in information about 50 million customers and about 2,000 different attributes they track for those customers. What they wanted to be able to do is build a much better, more intimate relationship with their customers. How many people here enjoy getting random spam texts? Right? So we don't like this, but how many people enjoy getting that offer? You'll go say, gee, I really wanted that. I used to often joke, I'd love to see in the mall where I'd go in and there'd be a store that says Dave's stuff. And when I went in there, the only thing I wanted was always right there in the middle of the store. I just had to pick it up and go. So the more intimate my vendor can be with me as a customer, in this case it's a telco, the more a good relationship I can build and give you meaningful and useful information and not bother you. So that was their goal. Their goal was to do this with an omni-channel marketing system. They're using a Scala framework, and they're looking at a reservoir of messages. They're looking at all of this information and telemetry coming in, 10 business lines, and, oh, actually, no, this is a bank. Savings accounts, home loans, credit cards, and they are now having 17,000 different types of nudge variants. With that degree of personalization and specificity, they're able to provide information to their customers in a meaningful and useful way that makes customers feel like you really get me without bothering them, which is a huge benefit for the customers. You get a better service from your provider, and a huge benefit for the bank because they're able to retain customers and grow their business. Now, this one here is really just about cost savings, reining in the costs of the monolithic environments, largely in on-premises data centers, the cost associated with that, the waste of resources. In these monolithic environments, how many people here have had to build these where you build them for the highest high water mark because some days you're going to need that power, and then you end up with like 70, 80% idle time for the rest of the year or the rest of the month? So we want to reduce that idle time, reduce the energy that costs us, reduce the money that costs us. And so this is a migration to a pure cloud environment. So this customer here moved everything into AWS with Cloudera on AWS and made Iceberg the table format of choice, moving all of that data in. So not only were they able to take 50,000 tables copied across all these monolithic systems and reduce it to only 10,000 tables to manage. 5 times reduction in the data sets you need to manage. That's a huge relief already. But also by being able to now take advantage of containerized services and auto scaling, be able to optimize the use of resources and have no waste. And that gave us a tremendously lowered total cost of ownership. This took about 6 months to do, moving 8,000 workloads to get them running on AWS, and helped save a lot of money. This is an organization we're working with that was moving towards the notion of data products. They still maintain an on-premises data center, and they are moving a lot of workloads to AWS. And one of the things that was really useful for this journey for them is the ability to modernize the on-premises data using S3 appliances. You can also use Cloudera's distributed Ozone on your existing hardware. Ozone's an S3 compliant object store. But the idea is running the same kind of storage in on-premises as I do in cloud and putting Iceberg into that so I have the exact same data format too. Same data in both locations, same capability in both locations, and running the same services in both with one security, one governance, one traceability, one view of all of that. So this data can now be shared as data products. So you don't have to be all in cloud to share data products with cloud business use cases. You can get access to the on-premises data and use it in cloud, or get access to cloud data from on-premises, or use the replication if you want to co-locate the data for those cases where latency absolutely has to be a minimum. What they got out of this was better access to analysis for what they were calling their customer well-being initiative. This was the telco we were talking to. They wanted to look for things that they called the silent complaints. They wanted to be able to see customer behavior that implied that they were losing satisfaction with them as a vendor and be able to give them personalized offers and personalized treatment proactively to keep them on. So this is something that really plagues a lot of retail-type organizations, is not everyone who's about to churn from your service or your products is expressing the complaints that make them want to churn. So if you can detect that some other way, you can be a much better vendor and have a much better relationship with your customer. So here, this is a life sciences data aggregator we're working with. Their main goal with this project was to incorporate live real-time telemetry from patient wearables, stream that data in together with all the R&D that they have on similar trials, medical images, structured and unstructured data. Some of this born in Google Cloud, some of this born in AWS, some of this born in on-premises data centers. So this is multi-cloud and hybrid cloud all coming together and at massive scale. The purpose of this, fundamentally, was to be able to allow more patients to do more recovery at home. How many people love being in a hospital? If you're not feeling well, where's the best place to feel not so good? It's at home. And what we've also seen in the medical science is that patients who are able to be at home will recover better, be at less risk for sepsis or other hospital-borne diseases. So getting you home, but being able to monitor you with the same quality as if you were in the hospital, this is a good thing. But the other thing they were doing with this is not only empowering hospitals to be able to give more adequate care to patients at home, they were also able to aggregate all of that data and feed that back into the medical R&D communities. Well, what they're doing is looking to be able to improve the time that it takes to go through medical trials, to reduce the medical trial time, to get to yes faster and no faster, and also reduce the time and cost that it takes to make life-saving medical devices and life-saving medicines and vaccines. By the way, this organization, nice little humble brag here, was instrumental in helping us find the COVID vaccine. Their life sciences data aggregation was part of that equation. And we talk about data democratization. Another organization looking to move to this data products notion. They were bringing in operational data, live data coming in from their operational systems in real time, combining that with unstructured and semi-structured data, and also taking some of the traditional dashboards and reports they already had in production. They weren't migrating those, they were just taking the output of those and including it in this project, and reduce the amount of data silos that they needed prior to moving from lake and house to a lakehouse, and co-locate all that information together. They were taking advantage of on-premises for safe and compliant full control of their data, while using the flexibility and performance at enterprise scale of AWS and cloud. One catalog sharing those data products enabled them to first use their tool of choice and avoid that vendor lock-in. By making data products that are technology independent, you're not forced to use a given vendor's solution to take advantage of those data products. So their business users and their data communities could continue to use the products and solutions they're familiar with, while the back office got a lot more organized and a lot more efficient. And even with no SQL environments, we had an organization using HBase, one of the largest NoSQL databases, or not only SQL databases, on the planet. Anyone here remember HBase? And it's one of those situations where if it isn't broken, don't fix it. But they were working on 2.8, 2.9 petabytes of data ingested per day. They needed to get a more flexible way to do that. So moving the store to Iceberg and moving the compute into AWS Cloud, moving the data into AWS S3, they're able to use structured analysis with Cloudera Data Warehouse and still do the NoSQL with the Cloudera operational database working in conjunction to give them an overall savings of 8% year over year in managing this massive influx of data. Saved them tremendous money, gave them a more flexible and adaptable environment, and they were also able to, because they were able to use the different AWS regions and the AWS S3 buckets as they stand in those regions, get a balance of regulation by region automatically through the partnership with AWS. So that brings me to the end of the presentation. We covered a lot today, why the lakehouse and why Iceberg is an important phenomena in our modern architectures today, how making a move to the lakehouse and taking in fabric and mesh capabilities and looking at your metadata in a new light will allow us to be able to move from where we are today to a data estate that's controlled and governed, allowing us to trust more data to more use cases and be ready for that next wave of generative AI, where we're moving into agentic AI on our most precious data, our most proprietary data that differentiates us, allows us to build industry's first or industry's best examples of AI use cases that move us forward in our enterprises against our competition. Because that's ultimately what we want to do, is we want to use AI for good, better value to our customers, better value to our businesses, and ultimately, in the case of health sciences, perhaps even save lives. All right, well, thank you for joining me today. It was a pleasure to have you. I hope you enjoy the rest of the show. And if you want to learn more about Cloudera, you can come down and see us in the booth we have down in the expo hall. Otherwise, have a great rest of the show. Thank you.